Hi, in this video we will learn about logarithms in different bases, and we will study a logarithm as a function. It's called logarithmic functions. Let us start with the definition of logarithm. So we first need to fix a base. Let be a positive number but 1. So any number, positive number, can be base but 1. Then for any positive x, log of x base b is equal to y if and only if b to the power y is equal to x. In other words, log does the inverse of what exponential function do. What exponential function, an exponential function base b does is that if you give me b, y, I compute b to the power y and give you what is that value. However, log, if you give x to log base b, will look for the exponent of b for which we have b to the power y is equal to x. So it will look for the exponent. So then in nature, log is looking for the exponent of a b to the power what makes that x. Let's do some examples and we go from there. Okay, so log of 8 base 2. What is the number? When you put in the power of 2, you get 8. Well, here you see 2 to the power 3 is 8. So that 3 is log of 8 base 2. How about log of 0.1 base 10? So we are looking for a number, an exponent for 10 such that we get 0.1. 0.1 is 1 over 10, and that is 10 to the power negative 1. You see that the exponent we are looking for is negative 1. 1 over 9, we can write it as 1 over 3 to the power 2, and then write it 3 to the power negative 2. So 3 to the power negative 2 will give us 1 over 9. So the log of 1 over 9 base 3 is negative 2. 0.2. Well, 0.2 is what? I can write it as 2 over 10, which is 1 over 5. And this is 5 to the power negative 1. Again, that is the negative. The power we find is the log. How about 4? Well, 4 to the power 4 is 4. So the 1 is this. Actually, in general, we have the property that log of b base b is equal to 1. That's obvious. Yes, b to the power 1 is b. And how about 1? How you can write 1 as 9 to the power something? Well, 9 to the power 0 is going to be 1. And that's another fact that you see always. So log of 1 base any b is equal to 0. And 0.25. 0.25 is, well, oh, the other way around, sorry. It is 25 over 100, and you simplify, you get 1 over 4. And if you like to try to write this as a power of 2, this is negative 2. 2 to the power negative 2 gives us 0.25. When it comes to log functions, there are two conventions which are important. If base is equal to 10, we usually don't write the base. So log of anything without base means, this means that we are choosing a notation, log base 10. This is like when you don't write any power, it means 2 to the power 1, or when you don't write any degree of radical, it means that it is 2, and so on. So here, if you don't write any base, it means 10. And the other one is when b is e, Euler's constant, Euler's number, then the log base e is a special function, and we have a different notation for that, ln of x. And well, in this case, we call this the natural log. Remember that when the base was e to the power x, the exponential function e to the power x is called the natural exponential function. Here also, if the base is and the base is the base is e, we call it the natural log. Well, we can take function as log as a function. So again, so this is a logarithmic function. This is definition. The logarithmic function base with base b is when you have f of x is equal to log of x base b. And well, when you have e equal to 1, the natural one, you have ln x. Yes, that's the one. But when you write it in this way, well, there will be some new things that you have to tell me what's going on. For example, what is the domain of log function? Remember, when we define the log, we choose x to be positive number, and that means that we can only plug in positive values there. So the domain is 0 to infinity. How about the range? Well, range of logarithmic function can be anything. So it goes from negative to plus. I will sketch the graph for you in a second, but you have to keep in mind that the value of log can be any number. The domain, however, is only positive ones. There are other properties. For example, a log is continuous function. So it is continuous on its domain. And log is differentiable. We will find the derivative in the next section, the differentiable function. Well, it is monotone. Log is monotone. It means that it is increasing or it is decreasing depending on b. And indeed, we have the graph for log functions. Here, well, if b is positive, well, it doesn't matter what is b first. If b is bigger than 1 and b is less than 1, b is supposed to be always positive. If b is bigger than 1, then the function will be increasing like this. It means that when we move to right, it goes up and up. And when we go closer to 0, it gets closer and closer to function, to the y-axis. In other words, this is a vertical asymptote for the log function. And this, for b less than 1, we have the other way around. So it is going to be decreasing. So let me write here decreasing. This is increasing. And again, the y-axis is going to be the vertical asymptote. In both cases, since log of 1 any base is 0, all the logarithmic function pass through the point 1, 0. 1, 0. And well, let me just write here f of 1 is 0 always, and f of b is equal to 1. So these are two things that you can see. Well, a remark is that when we have a ln function f of x equal to ln x, since it is log base e, since e is bigger than 1, is going to be increasing function. It means that the graph of ln is of this form. Well, this was a very quick introduction to log and logarithmic functions.